Hi, everyone. Thank you so much for joining us today. I'm Anthony Romeo with Occipital AI, and today I'm going to introduce to you V-CORTX, our new AI vision platform. So Occipital AI has been around for a little bit over a year now, and we spun off from soft robotics, and we've really been focusing on the machine vision side of automation, specifically in the food space. We understand that AI has been a huge buzzword recently, and everyone is trying to inject AI into their solutions. And today I'm going to tell you a little bit about why V-CORTX is different than some of those solutions you might be using before. So with traditional machine vision, it's very good at highly repeatable parts. When you get into the food space, there is no CAD file for a chicken wing. And your first thought might be, wow, food is a incredibly challenging application, and there's going to be so many images that I need to label and annotate, and I'm going to have to get really good at the CAPTCHA and identifying different things. With V-CORTX, we don't believe in any of that. We have no code, no images, or no image annotation that you'll need. We know that a lot of these AI solutions out there today require a lot of images of the solution in production. Someone has to go and label those images, and we think that just takes too long. So what is V-CORTX? Well, there's really three key components. There is our AI model manager, which allows customers to load in pre-trained object models that are developed at Occipital AI. There is the recipe builder, which really tries to keep customers in control. We understand that every application is a little bit different, especially in the food space. Recipe builder is a way for customers to key in solutions directly for their application. And then the analytics dashboard is showing all of the results. So it might be great that you deployed this AI vision solution, but how is it going to make you money? How well is it doing? All of these performance metrics can be tracked in our analytics dashboard. So I could show you some more slides, but I think people are getting tired of slides and they're a little bit boring. So I'm going to dive in and really try to show off what V-CORTX can do. So I mentioned it earlier, but at Occipital AI, we develop pre-trained object models for the customers. Now, what does that mean? If you've worked with any traditional machine vision AI solutions in the past, once you start the training process, you have to take a picture of some type of food. Maybe you take a picture of your donuts. You label, this is a chocolate donut, this is a vanilla donut, this is a glazed donut, and you do that again, and again, and again, a couple thousand times. And part of the reason we believe that this approach is fundamentally unsustainable is that me labeling on a Monday morning when I'm locked in versus 5 o'clock on a Friday when I'm trying to dip, there's going to be some variance. My labeling versus a coworker's labeling or my boss's labeling. It's so error prone. There's so much human subjectivity that it really doesn't lend itself to accurate results. Instead, at Occipital AI, we'll run 3D scans. So what does our solution do? I can give a couple examples. Here is V-CORTX inspecting donuts, and it's classifying what each donut is, what type of donut, and if there's any defects. You can see here it's getting the frosted, it's getting the one that has the flower shape, it's getting the crushed donut, the Boston cream, and the jelly glazed. You can see we have some other applications. Here we're looking at pork loins. We're identifying the fat content on each pork loin. We can also take a look at prepared foods. Here we have Capri Suns. We're identifying the straws in the label to make sure everything's good, and we're sending bad ones back to be reworked. There are a ton of different products that we've worked with, and we have developed object models for all of these. If you are a customer of Occipital AI, you are not going to have to take any images. You are not going to have to do any of the training. We have already done the training, and we are putting it into your hands. So even if you're not a machine vision AI expert, you can still leverage these tools. So I've shown you a number of examples, but really let's get into the technical side of why we are different. So again, I said we don't use any images or don't do any labeling. Well, how do we do it? So we will take a full 3D scan of the product that we want to work with. So we have a little 3D scanning camera. We will encompass all of the corn, and what that creates is a 3D digital asset. So here you can see a real piece of corn that we scanned in 3D space, and we can spin it around. We can look at the front. You can see that we have some husk on here that we captured. We know the pixel, all the colors. We know the texture. We know everything there is to know about this. And we're not just capturing our scanner with 2D imaging, but also a 3D LiDAR component. So we have all of the dimensional information of how long this is, how wide it is. We have everything we need to know about this piece of corn. And we'll do that for a representative number of products. So maybe we scan 10 different pieces of corn that all are a little bit different. Some maybe have husks, some don't. Some have some really bad tips in the front. You can see this one. The front is really gross, got kind of chunked out. Once we have a representative amount of the products, we can start deforming these in 3D space. So if we see that tip fill, we can recreate it on other assets, which with 30 scans, we can create hundreds of thousands of different images. So once we have all these digital assets, we need to use this training data to train our AI system. So again, instead of hand labeling a scene, we run synthetic data generation. So with these assets, we know we have a customer that's working with corn dogs, and we know that their application, there's a ton of corn dogs in the scene. They're going to be all overlapping all over the place. And this customer has a blue conveyor belt, and they know that their lighting is pretty standard all the time. So we will say, let's generate a scene with 20 corn dogs from our library of 30 that we've scanned, and let's run a simulation. And you can see here that we dropped all these corn dogs onto the conveyor. And instead of having a person label, this is corn dog 1, this is corn dog 2, this is corn dog 3, you'd be here forever. We know how many corn dogs there are. We know the position of all of those corn dogs. We know all of the dimensional information about all those corn dogs. And we use that to train the system. And we'll say, do it again and again and again. And we click run, let this simulate hundreds of thousands, if not millions of times, can walk away, go grab a coffee, start loading up another one to train. And when we come back, our system is trained on hundreds of thousands of images that are more accurately and correctly labeled than traditional 2D hand labeling and imaging. Another great benefit about this is this maybe could be solved with traditional machine vision or other AI solutions. It would take you a while. But say that customer has a retrofit, and now they don't have blue conveyor, now they have white conveyor. You have to go in, you have to stop production, you have to take all those pictures again, you have to label all those pictures again. You're right back at square one. It is extremely cumbersome, and none of the product changed, just the conveyor changed. For us, all of those scans are still good. We can still use all those scans to run data gen. They didn't change their corn dog manufacturing process, but now they're running a white conveyor. And you know what? In addition to their white conveyor, they have a more open plan. They have more windows. They're letting more sunlight in, and the lighting environment has changed. So there's more lighting variability. We can just run synthetic data generation for a different conveyor type or a different background, and we can do this in minutes. So we would run this simulation, we'd go off, get another cup of coffee, and this thing is off to the races running. The iteration process is so much quicker, which allows us to deploy and iterate in days or weeks, not months. So all of this is incredible, right? We're not doing any imaging. We're not having to label anything. We don't have any code. We have 3D scans of food, and we're delivering customers pre-trained object models. Well, that all sounds great, but with flexibility and working out of the box, it's a very fine tightrope. Anything can work out of the box if it just does one thing and there's no customization, but how valuable is that really? On the other side, someone could give you the code library and let you write your own API and make all these calls, but that's not really that easy to use. With AI, it's very much about finding this balance, and we think we've struck absolute gold here at Occipital AI with V-CORTX. So we're going to stick with this corn dog example, and here is our recipe builder. So this is what integrators would have access to. So on the right side here, you can see we have the RGB image of corn dogs. This one has a massive chunk taken out of it. This one also does. This one has a smaller chunk taken out of it, and let's note all that. Down here in our inspection, we are looking for display spreading, and essentially the system is classifying things that have display spreading and corn dogs showing of 200 millimeters squared. That minimum area will classify this as display spreading. So you can see this one is not getting that display spreading categorization, even though we are seeing some display spreading and some hot dog. How would one of our customers address this? Well, we have trained this object model and we're very confident in it. We know it's identifying that display spreading, but different customers have different requirements. So for this display spreading rule, for it to count as display spreading, it needs to have a minimum displaced area breading or a minimum hot dog area of 200 millimeters squared. I happen to know that this is 117. We have some other debugging tools if I were to go into our test view. But for the sake of this demo, if I were to go in and change this 200 down to 50 millimeters, it now doesn't need to see a huge 200 millimeter area, it just needs to see a 50 millimeter area. I'm going to save this recipe and I'm going to reload it. I changed none of the object model. I didn't have to do any other training. I just went in and changed a hard rule about the system. And now when we click test, we can see that it did correctly identify that product with the display spreading. This is really powerful because we understand that each application might be slightly different based on customers' needs. We have done some work in the past around frozen pizza. And if you are manufacturing frozen pizzas for Walmart versus Target versus Stop and Shop, Walmart might really care about the pepperoni distribution and they are on a mission. They will not send a pizza out that doesn't have the perfect distribution of pepperoni on the pizza. Stop and Shop might not care a ton about the pepperoni distribution. They're a little bit more lax, but they really care about any burned crust. They had a customer complain about a burned crust that was one of the C-suite's children, and they are on a quality mission. They will not let that slide. What you would do here is in the inspection rules, you could have the Walmart job have a bunch of rules around identifying different pepperoni, but not have too many rules around burnt crust. You're now no longer running the Walmart product, but you're running the Stop and Shop product. You would just load in the new recipe. The object model is still identifying the same pizzas, still has the same conveyor background, but now it's a different application. We think that this blend of user control lets users control the AI without having to fundamentally understand how it's trained or how it works. We think that these operators and integrators that'll be working and using Recipe Builder, they know their application a lot better than we would at Occipital AI. On the flip side, when it comes to training an object model, I am 100% confident that our team of AI engineers can train a system a lot better than some of these people in the field that might know their application. So this recipe builder is completely rules-based. There's no Terminator fear of it going rogue and making a call of, I think that this is going to be a defect now. It is hard-coded, hard rules, and we think that customers understand that and want to be able to have those hard rules and be able to change those thresholds. So we showed you how we create these models and how we're novel from everyone else in the market. We also have shown you how we have a different level of control compared to everyone. But where does all this data go? How can you use all this data? Our final piece, the analytics dashboard, aggregates all of this information and displays it to customers in an easy to understand, digestible format. We understand that with the new digital era, data is very valuable. Everyone wants data. Everyone can give you data. The data is only as good as how well you can digest it. So we've worked with food manufacturers to try to really key in on some key metrics that matter in the food space. So here are the corn dogs we've been running. You can see that this was a 24-hour clip from yesterday. We have this calendar we can drill in. It looks like we ramped up a little bit and then we hit a flow state from maybe 7 to 10. It looks like we have a really big dip in our lunch production. Maybe that's fine. Maybe that's something we want to address. And then it looks like the second shift is a little bit slower. Now, all of this information is good, but it really allows you to look at trends and critically think about your manufacturing process. We have the second shift is a little bit slower. Maybe we need more staffing for the second shift. Maybe because we're less effective, we don't care and we're going to cut the second shift. Maybe this lunch dip is everyone's off for lunch and this is awesome that we're still getting half productivity. Maybe this is unacceptable and people are taking lunches too long and skirting the system and we need to have some training. We can also go in and if we really wanted to drill down on the first shift, we can highlight this area, and now we have more granular detail about that area. It's, again, really good at being able to go in, drill down, and see exactly where these defects are lying. So the first part is throughput. We also have yield. You can see here that we have a dip in yield, but we're doing the same number of products. That's because we were seeing a lot of bad product. So you can see this dip in yield directly corresponds to the spike in defects. We were still moving the same amount of product, but a lot of that product that we were moving was bad. A lot of systems out there today can tell you if there is a defect or not. Something novel and very powerful with Occipital AI and V-CORTX is that not only do we tell you a defect is present, but we tell you everything there is to know about that defect. So if you had a genie and could make a wish and wave your magic wand and fix something, it would be pretty foolish to fix the missing stick defect when the broken stick defect is a lot bigger representation. Also, if you were to put on your hat and be Sherlock Holmes, Sherlock roams on the case, what are we doing? The missing stick issue might be a different root cause than the broken stick. The missing stick to me sounds like some machine isn't correctly putting a stick in. That is where I would start looking. A broken stick, to me, the stick has been placed correctly, so it's not there, but somewhere it's breaking. Maybe I would look at where in the process things are falling off a conveyor and if broken sticks are occurring right after that. It really lets you key in on these defects, understand what the root cause is, and be able to take preventative action. We're not showing burned corn dogs here. That is a issue that customers face. In addition to having these metrics on a analytics dashboard, we could in real time send an alert. If we see that there were 7 consecutive burned corn dogs, I can make a pretty good educated guess that the 8th corn dog is also going to be burned. I can also make a pretty good educated guess that someone upstream needs to turn down the oil temperature or increase the conveyor belt to prevent that next one from happening. There's going to be more defects that keep coming until someone takes action to remedy those defects. With V-CORTX, we could send off an alert. Hey, we just saw 5 consecutive burned ones. Might want someone to turn down the temperature. We can also go in and take a look at just one type of defect. If you have a recall and you want to look at these defects, we have a film strip that shows all of the images. It's really powerful for troubleshooting. So here you can see, here are all the corn dogs that we identified that had a broken stick. We can look at each one and see the segmentation of the stick, where the corn dog is. We have dimensional information about each corn dog that we see. We can see not just for defects, but the overall aggregate information. If you were changing your packaging and you wanted to make sure your package still fit all of your product, we have histograms here that give dimensional information. You can see the most common length is between 164 to 171. We have some outliers that are really long that are above 188, and some of our shorter outliers are below 147. Again, we built this with food manufacturers. We really think this is a powerful tool, and this is great for C-suite people getting a bite at the apple of what is really going on in production. It's great for operation people who are on the floor that really need to go in and make these changes. It's good for quality managers if you wanted to have a Kaizen event and figure out where you should focus. A lot of powerful information in our analytics dashboard. So again, that is really what encompasses V-CORTX. The 3 key things are the AI model manager, where we can have customers deploy pre-trained object models that are developed at Occipital AI. There's the recipe builder, which keeps users in control and allows them to key in on their application specifically. And then we have the analytics dashboard, which is going to aggregate all of that information and display it to you in a very easy to understand, digestible format. So I know with our launch of V-CORTX, there have been a couple questions that we've been getting. So just to get ahead of these questions and address them, first of all, who is V-CORTX for? Great question. We really have 2 key target audiences, and they kind of correspond to different applications we can solve. If you have an application that requires inspection, maybe you're looking at a bag of peas and carrots and you want to make sure the right ratio of peas and carrots is present. And if you have 100 peas and 50 carrots, someone's going to add more peas and you don't need to do any robotic picking. We can sell directly to end customers. Our target audience would be like a plant manager, a quality manager, an operations manager, someone who's on the floor living this day to day and can see issues in the current assembly manufacturing process. When vision guided robotics or picking solutions are required, you're looking at different Capri Suns and you see one doesn't have a straw and you want to pick it up and put it on a reject bar. Because we are a machine vision company, we don't manufacture the robots like a Fanuc, an ABB, or a Stabile would. We have to work with an integrator to help come up with a solution. So our end customer in this case would be integrators. We would provide to them the vision solution, and we would explain to integrators why our vision solution will make it a lot easier for them to deploy, a lot easier for them to integrate, and allow them to tackle some picking solutions that wouldn't have been possible in the past with traditional vision. Next question, what makes V-CORTX different from other AI vision platforms? Great question. I hope that as I was giving the demo, I was trying to highlight what makes us different. But I think really if we wanted to dive in, I've got the slide here. Traditional AI vision requires customer to go in, take a bunch of pictures, and then label them. If you've ever been online and try to check something out and you get the, make sure you're not a robot, click all of the images that have a bike in it. Draw a box around this tire. Click the areas that have a truck. All of these things are being used to train systems. If it has enough information, it can see an image that it's never seen before and say, I have so much training data on trucks and where they are that I know there's a truck here. While that might work and some people might see some success, from what we have found, that process, there is a learning curve. And it is possible to give bad training data. If you train these incorrectly, the system will not work. And if you don't have a degree in this and don't have a ton of experience and it's your first model that you're training, you're not going to know what is good and what is bad. We have a team of machine learning engineers here who work a ton with AI and have different diagnostic tools to be able to understand behind the scene what's going on. Because of that, we don't require any images. We can pre-train our vision models. There's no coding required on the customer side, and we can deploy in weeks and make iterations in days. Again, with traditional vision, if you were to do a retrofit with the conveyor, it's not as easy as just, okay, run white simulated conveyor instead of blue simulated conveyor. You have to stop the line, you have to go to the customer site, you have to take images, and to take the images, you need to you have to have product running, and it's very cumbersome, very time consuming, and customers are getting very frustrated that they get promised something that'll work that doesn't work and takes a lot longer. So I think, again, to sum it up, we use 3D scans and synthetic data generation, which allow us to get a better, more accurate pre-trained object model for the customers. So those were our questions, and that was an overview of V-CORTX. It's a super exciting, awesome platform. In the beginning, I was showing off a bunch of different products that we've worked with. We have existing object models for all of those products, so give us a call if you see something there. We can work with you very quickly. If you didn't see your product on that list, give us a call anyway. We love to tackle new applications. We can spin these object models very quickly. And if there's a use case for it, we would love to know about it so we can start working on it. Thank you so much. I hope you enjoyed this presentation on V-CORTX. Have a great day.